Good morning, Algebra, day 2, and we are on 12.2. And today we are continuing with quadratics. Hope things went well yesterday. Didn't hear from any of you guys, which is a-okay, but I hope you're all doing really well. Praying for you guys. As you probably very well know, this is a time to stay close. Today, we're solving quadratics by eliminating our equation, rather eliminating the exponent, taking those roots. So if we have something like this, we can tell that it's the difference of conjugates, right? That's one of those patterns, those special patterns that we could follow. And then we find out that our answer is x equals plus or minus 8. Well, a way to solve by taking the root is to isolate the squared term, right? That's this x squared. Get that alone on one side of the equation, and then to square, of course, both sides of the equation. Here's what I mean. So with that same example, if we isolate that x squared, and then take the square root of both sides, we know that with the square root, typically we're just going to take the positive answer. However, we know that the square root of 64 is both 8 and negative 8. Negative 8 times negative 8 is also positive 64, right? And this is the same answer that we had up there. So here we're factoring it using the special pattern, the difference of conjugates. Or here we're just solving by taking the roots. Okay, this is making sense. We could do the same here. We're going to isolate that, adding 24 to both sides. Then we're going to divide it by 2 to get rid of that coefficient. Bada bing, bada boom. After simplifying 12, doing the little factor guy, so it's going to be plus or minus 2 root 3. Okay, hope this is making sense to you guys. Whether in the video or in an email, go ahead and give me a comment whether you guys are totally in the dark or if you're able to follow along, okay? I would appreciate that. Now, with this process, we could use the same procedure for reversing, right? Taking the square root of a squared term, right? Those are inverse operations, so those kind of go back and forth. So if I had x plus 2 equals 36, that should look like x plus 2 x plus 2 squared equals 36. This is how it looks at first, and then it goes over there. Then I take the square root of each side. Then I find that x plus 2 equals plus or minus 6. Well, in this case, now I need to separate it. So I'm going to say x plus 2 equals positive 6, and then x plus 2 equals negative 6. I still need to solve for x, but I've got both the positive and negative terms. So now that I've got both the positive and the negative, I'm going to solve for x and find out that x equals either positive 4 or negative 8. Again, let me go over that because I could just imagine each of you going, huh? Right, Veronique, you're making one of those faces right now, and Elena's like, excuse me? I hope that was a good Elena impersonation. We start here. You'll see things like this where we have a factor and it's squared equals something else. Well, again, we could do the reverse for a different, right? This is a polynomial, many terms. We can take the square root of a polynomial. That's what I'm doing right here. This is step 2. but whenever you take the square root of something, the answer is either the positive or negative of that term, right? So the square root of 36 equals plus or minus 6. Now the square root of this is just x equals 2. Okay. From here, I still need to solve for x. So I'm going to set the positive 6 over here and then solve it, bam. And then x plus 2 equals negative 6 is going to be down here. So this goes both yeah and yeah. Okay. All right, moving on. Hope this makes sense. Again, ask for help if it don't. All right, here's another example. Again, this is starting at this example is starting at x, was it minus 5? X minus 5 squared equals 21. How are we going to get rid of that square? Well, we're going to take the square root. What we do to one side of the equation, we have to do to the other. Very good, very good. So we're doing that. Now, I don't know the square root of 21, and in fact, it cannot simplify. So I'm going to get x minus 5 equals plus or minus the square root of 21. Right? The factors of 21 are 3 and 7. There's no pairs there. There's no squares. I can't simplify it. However, I still need to solve. So I need to isolate this variable, so I'm going to add 5, but I can't add to this with an integer. Just doesn't work, right? They would need to have the same radical. I don't have that. So I'm going to get x equals 5, right? Adding 5 plus or minus the square root of 21. Once you leave it like that, that's your answer. Aren't you glad we're not taking the test till we get back to class? Okay. I do have some practice things here. Let's see what this looks like. Here's one. Go ahead, pause the video, write it down, do your best. Hope you paused it, because here's the answer. Again, let me walk it through this with you guys. So I'm trying to get all my x squared terms to one side and all my regular integers to the other side of the equation. So I'm subtracting 2x squared, bing bing. It's going to give me 5x squared plus 6 equals 8. Subtracting 6. 5x squared equals 2. Divide by 5. That left me with x squared equals 2/5. Then I got to take the square root of that. X equals plus or minus 2 root 5. Or rather, plus or minus the square root of 2 over 5. But luckily with number 2, not all of them are that ugly. Here, my x squared term is already, maybe you should pause it to work on it. Okay, I know you paused it because you're all perfect little angels. So I'm going to take the square root. What's the square root of 21? That's right, plus or minus 11. Woo! Yahoo! Okay. This guy here. X squared minus 16 equals 0. Again, this is a special pattern, difference of conjugate, or we can do it the way we're doing in this lesson and end up with x equals plus or minus 4. I don't know what was going on here. Let me just fix that. Okay. This one, it looks like it was x plus 3 squared equals 121. Okay. taking the square root of both sides, x plus 3 equals plus or minus 11. Again, I need to separate that into the two different expressions, rather equations. X plus 3 equals the positive 11, right? That's the plus. Or x plus 3 equals negative 11, right? That's the negative down there. Okay. So again, solving for x, subtracting 3 from both sides. That gives me x equals 8 or x equals negative 14, same thing. Here's the final one. Oh, you guys are going to like this one. Let me get the shadow out of the way. So I need to divide by my coefficient again. That's negative 4. Well, that gives me x squared equals negative 16, but cannot take the square root of a negative number, but the square of a negative, or the square of a number may be negative, right? That's where we get plus or minus. Here's a note that can confuse a lot of students. So we cannot take the square root of a negative number. That gives us no real solutions. NRS, no real solutions. So you can't take the square root of a negative number, but the square root of a number might be negative. Might be confusing, but I hope this helps you guys. I'm going to come on a little bit later, probably an hour or two, with work on the quiz. Otherwise, I love you guys a bunch. Bye.